Hello?
Hello, could you set up Qdrant on a Linux server?
Yep, alright.
Hello, so today I'm looking at installing a Docker container on Webdock. Webdock is some really good hosting that I use. I've got a Linux Ubuntu Jammy LEMP 8.1 image running. So I've created the server. There's a really good guide on installing Docker. So what I want to do is install, ultimately the purpose of this is to install Qdrant, which is a vector database. And once I've got the bits and pieces set up, we will hopefully be able to do this and expose our Qdrant Vector Database. So let's get started. So I'm going to go back to the instructions. Make that a bit smaller. First, uninstall the old version of Docker if it is already installed. Let's just do that anyway. Unable to locate, that means it wasn't installed. Good. Sudo apt-get update. This is a brand new server, so it probably have a few updates. And it's pretty quick. Okay, it's complaining about the key is stored in legacy trusted GPG keyring. That's all right. So install necessary packages to allow apt to use a repository over HTTPS. So install CA certificates, curl, GNUPG, LSB-release. Yep. Hopefully the font's big enough. I don't want to make it too big because then it just gets difficult to use. Add Docker's official GPG key. Just using curl. Set up Docker's stable repository using the following command. So echo deb arch equals dpkg, print architecture, etc., etc., download Docker, Linux, yeah. Okay. Update the apt packages. Then install the latest version of the Docker engine and container D. 401 megabytes, it's all right. Then we'll be enabling and starting a Docker service. Sudo systemctl enable Docker service, sudo systemctl start Docker service. Cool. Then sudo usermod -a g, that's add it to the group, I believe. Docker, add the current user to the Docker group. To activate changes to groups, run the following command. Sorry, the microphone's a bit close, I think. Okay. Check the Docker version. It looks a bit daunting when you, there we go, so. Go for the good old hello world Docker message. Enable to find locally. Hello from Docker. So that's working. Good. The documentation on Webdock is excellent. It's been really, really thoroughly and accurately written. Changing storage driver. You need to skip this step if you're installing Docker on our KVM servers, as our KVM servers support Docker's overlay. So I'm not on a KVM, I don't think. So we'll do sudo apt install fuse overlay. This will significantly reduce Docker disk usage and makes deploying containers a bit faster. Sounds good. So next, we need to tell Docker to use the new storage driver. We create a JSON file in the Docker directory. They're saying they use nano here. I guess they don't want to force people to use Vim. That's a bit cruel, isn't it? Oh. Ah. Sudo system. So restart the Docker daemon. All good. Now run the below command to check if the new storage driver is effective. I'm going to check for the Docker storage driver. Storage driver, fuse overlay fs, good. Right, managing Docker images. In order to run a Docker container, a Docker image is required. Use the following command to pull the Docker image from Docker Hub. We're just going to pull down nginx. And then we'll list the images, and we should only have that. Good. To remove a Docker image, use the following command. The above command will remove the image with the latest tag from the host machine. For example, if you have an nginx image with the tag version 2, then nginx. Okay. To know detailed information about a Docker image, in this case Docker, let's just do that. Wow. Okay. I don't actually use Docker that much. I try to maintain a laser focus on Python and Rust, but a container is created from an image. Yeah, right, let's do that then. So we have now created the container. The above command will create a Docker container with a random name from the nginx image. Multiple Docker containers can be created from a single Docker image, although the name of the Docker container can be specified while creating it. A Docker container can be created and started using a single command. Add the detach option to run the Docker container in detached mode. Okay, let's go back up a bit. So where do we get to? Docker create. I don't know if it'll let me yes, it won't let you delete that. So Docker create. Will it let me do that? Yeah. So start image 1. So that's create. Yeah, so we wanted to do it in detached mode. So okay, so we're running nginx-3 in detached mode. Default Docker network does not allow the container port from the host machine. Does not allow access to the container port from the host machine. In order to access the Docker container port on the host machine, the containers ports are mapped to the host machine. Right, so we need to do that. So it will run the Nginx container and map port 80 of the container with port 8000 of the host machine. So you can access it through port 8000 of the host machine. Okay. In the case of Webdock, perfect service stack allowed traffic on port 8000. So we just got a Linux firewall. And okay, we're going to map. Use the volume option to map Docker volume to the host machine. List all the volumes. So we can see we've got an Nginx volume. View all the processes. And these are all the ones we've created because we keep going, 1, 2, 3, 4, 5, and so on. So number 5 is the most recent one with the volume. So yeah, we can stop a container. So let's stop number 3. Let's remove number 3. To remove a running Docker container, use the following command: docker rm -f nginx 5. So I'm guessing the -f is false. Getting into the Docker container. Let's go Docker logs. Is Nginx 4 still running? Yep. Docker container inspect. Okay, let's look at that. Oh, that is a lot of information. Okay. Check resource utilization by Docker container. We've got mem usage block. Okay. Conclusion. This article showed the installation steps to run Docker on a Webdock Ubuntu server and some basic commands to manage Docker containers, images, and volumes. Okay, so next, let's try and do the same with Qdrant. This is going to get the image. So we need to run that detached really, because oh no we don't. Let's just run it. Okay, we won't run it detached to start with, so let's just get that up and running. So it's running, but it's obviously only running whilst the terminal session is running. In fact, let's open up tmux. Oh, tmux is not installed. If you've not used Tmux, it's brilliant. The only drawback with it is the default kind of key mappings. This is where I've forgotten what they are. Is it Control B? Control B. Yeah, got it first time. So we've got 2 panes, which is really nice. There's no history because it's not going to pick up the history from what I was doing just now, which is fine. So let's move that over there. This is so good with Linux where you just keep on top. Don't you think Windows does that? Right. So we've got that. Yeah. We'll run that down here, and then we do Control B. Yeah. Look at that. Tmux, you can, if you go to / and then do, is it .conf? Tmux.conf? I can't remember, but just look up tmux.conf and you can really customize Tmux. I think I've got a gist on my GitHub for a nice nice Tmux config. So we've got it running. What next? I don't want to do all that just yet, so what to do? Right, let's go back up and go up through this again then. So did we when we started, oh come on, go back, got too many tabs open. Oh, I don't want, there we go. Oh, let's just test it with curl. Let's go to the quick start guide. Okay, so yeah, that's got the Docker steps for Qdrant. I've got theirs for you for starting up with storage. If you scroll down, there's some curl commands. I'm just going to try the curl commands rather than start messing about Python to start with. So, wow, it's working. So, as you can see, we've got we've got a test collection. So we did put, and we went into collections, and then we just created a test collection. Expected response. That doesn't actually. Okay. There we go. Wow. So, test collection. Result. status green. That's good. Oh, vector count 0 because we've not actually put any vectors into the. So they. You can see this. This is written in Rust, by the way. So Actix X is a cargo. Oh, sorry, it's it's basically a cargo module that you can add, which then gives you all the classes to do kind of to build an API basically. Axum is, I prefer Axum because it's kind of, it looks like it's going to take over eventually, but Actix X was maybe the dominant one a year ago. So I guess anybody who started writing Rust web servers and APIs a year ago would have chosen Actix X, and then it's kind of, you have to stick with it. But I think Axum is growing in popularity and possibly will become the dominant one, but it doesn't really matter, I'm sure. I think the performance is almost identical. Okay, right, let's carry on with expected JSON I should have just done JQ after it, shouldn't I? If you don't know this, if you're kind of new to some of this stuff, just pipe and then JQ. And that didn't work. Why did that not work? Oh, because I've not installed JQ. Sudo apt get install JQ. No, if we run that curl command with JQ, there we go. See how much nicer it is. And then we could do less. You see, status green, still no vectors. We'll get to that in a minute. Distance. So there's with vectors, there's different ways of kind of comparing. So you've got cosine, you've got Euclidean, and you've got dot, which is like product. Kind of from, if you know about product in mathematics, then that's what dot is doing. Let's go down. Okay, so nothing to worry about or to get to pay too much attention to. So let's actually go for. I'm just going to run through this in curl, and then we'll go back and we'll maybe go back and look at the Python bits. So what you can see here really is this is the put into the test collection points, and points are these. So going to put 6 lines. So I'm thinking we'll have 6. Will it say 6 vectors after we've done this? I think it should. Let's just run that. So that's not cut. It's not. I didn't cut it. Right. Copied. Let's do clear on that. Right. Paste in that command, that kill command. And there we go. It has inserted status complete. So now if we run that, let's clear again. It just looks messy otherwise. Right. Vector count 6. That's what I was wanting to show. Points. So don't ask me what the difference between a vector and a point is. Not unduly not unduly worried about terminology or the kind of the real fine details at the moment. I'm still in kind of getting stuff to work phase. Right, so the next thing I want to do is see if this is publicly viewable. So if I go to this URL 6333, and it is publicly viewable, so that is exactly what I want, because so I've gone to the public IP. I've put in port 633, and it has shown me that it is running. If I put that in instead, I thought that's what I just made, was test collection. I'm kind of just going off piste a bit here, so sorry. Right, so the ultimate aim of this is then to progress to loading up some vectors into this Qdrant database, which is running as a Docker image. So now I've had a little experiment with it. What I need to do is then just shut it down, open it up in detached mode, load it with some data, which if you go to Qdrant, then there's this Colab notebook, neural search demo, and it shows you can get startups_demo.json. You load that into a data frame, then you kind of process that, you iterate through it, and you encode it into vectors, and the vectors 384. In one of the examples, they're actually using 768, and I had that earlier when I was inserting. Let me just show you what I was doing earlier. So I had this running earlier, and when I ran it, I don't know if it's still in the history. No, I think I've gone. Here we go. So if you run the Qdrant example, somewhere in the code it has 768 as the dimension. Don't use 768. You want to be using 384. If you use the wrong dimension, you get an error. You get this message: wrong input, inserting error, expected dim 768, got 384. Once you then correct that, you'll find that you actually do get some good insertions. And yeah, if okay, let me just run this now. So this is one I did earlier, but I did this with a Qdrant image. I need that running. This is a nice thing about VS Code. You just switch between your sessions. This is basically doing what I was doing with Tmux on. So I'm not on the Webdock server now. Now I'm on my local machine. What am I doing? I need to show you this. So this is, what did I call this? Here we go, P1. Normally, rather than sort of test.py, I tend to just call stuff P1, then the second file's P2, and so on. Right. If I run this, what it's going to do is it's going to encode my query, and then it's going to search for where my encoded query is similar to my encoded data. And if we make this bigger. It finds 5 startups. So the query was take a random description as a query. Yeah, so what it's basically done is it's gone to record number 1, 2, 3, 4, 5. It's looked up the description of that record. It's then encoded that, and now it's using the encoded record of 1, 2, 3, 4, 5, which evidently mentioned dentists. Sorry. And so dental transparency provider, that was what it was going to search for, and then based on that, it's done a semantic search across the populated Qdrant database, and it's found a startup, Dainty, another one called Smiley, and so on. It's found 5. Why is it found 5? Because we passed in 5 there. So that's slicing, so it's -5 up to the end. So it's from the fifth to last up to the last. So there's a bit of pandas and NumPy going on here, which yeah, you can do it without. There's other ways, but horses for courses and all that. So that's the Qdrant example that I've kind of copied and pasted out of here. I think just running running their code, you kind of take it for granted that it works and you don't remember it. So I just kind of take out a chunk, test it, break it, and so on. When you see examples in what's it called? Colab, you'll see they've often got device equals CUDA. You need to take that out if you're running it on your local machine. That ran when they did. Yeah, so when they encoded all of their descriptions, according to this, it took 39 seconds. When I did it on my aging Dell Linux laptop it's about 5 years old, it took about 12 minutes. So just to give you some idea. To get the fast GPU stuff on Colab, you need to subscribe. Oh, yeah. Subscribe to this channel, but yeah, you'd also need to subscribe to Google Colab. But Qdrant, so blog.qdrant.tech. Oh, it's actually Medium. So Qdrant is kind of the model. Qdrant is the vector database, and then at the end of this, they've done a fast API front end. But that's not my plan. My plan is to do something else, which I will hopefully build and show in due course. So this is written by Qdrant developers, but it's on Medium by the look of it. So that's kind of like showing what the encoder does. So you've got a cat up here, another cat up here. So they're very similar. So they get encoded into a similar encoding. And then you've got a dog, which is down there somewhere because it's different. So obviously that's with image search, and we're dealing with semantic search of sentences. Semantic textual similarity, STS. So that's kind of what I'm going to be delving into. What tasks is neural search good for? Neural search has the greatest advantage in areas where the query cannot be formulated precisely. Querying a table in a SQL database is not the best place for a neural search. On the contrary, if the query itself is fuzzy or it cannot be formulated as a set of conditions, neural search can help you. If the search query is a picture, sound file, or long text, neural network search is almost the only option. I just realised, do I look really fat? I look like I've got an enormous stomach. It's partially perspective and partially because I'm slouched down in my chair. Anyway. So actually this is kind of the written article, which is the prelude to the Qdrant notebook, Colab notebook, which I just showed you, which was the prelude to what I did in VS Code, which one thing to note, if you try and put it all into a Python file, when I did the encoding, it took about 12 minutes. And then when I tried to run the code further down that relied upon that, I had to do it all over again. So just remember to do, I think it's mp.save. And you get basically a NumPy, vectors. It's basically a binary. You can't open it. Yeah. Whereas if I'd been doing it in Colab, following their Colab, or when they did it in Colab, that was already stored in memory, so that you didn't have to encode it all over again. So that's why when you do a lot of this stuff in Colab, it works really nicely. When you try and break it down into Python, you do need to split it into separate Python files, because you want one file which will do the encodings, but you'll only want to run that once. And then when you run your queries, you'll want to run your queries lots of times. So you need to have a Python file for your encoding and a Python file for your queries. When you're running it in a notebook, it doesn't matter, because you just keep going between the cells and they both work. So yeah, my next step is to use my own data, because I've started a project where I've effectively scraped my own data. This example uses their startupslist.com data. So I need to understand how they did it with their data, and then I need to make my data a similar format, and then, yeah, the good old monkey see, monkey do. And yeah, run the Docker. The Docker, so when I followed the Webdock instructions, yeah, detached. Here they don't mention anything about running it detached. I think I'm right in saying if you don't run it detached, then when you exit the session, then does it stop? I can't remember. That's the other thing. Yeah, the 768. So the 768 in this article, when let's just read this. The vector size parameter is very important. It tells the service of the size of the vectors in that collection. All vectors in a collection must have the same size. Otherwise, it's impossible to calculate the distance between them. 768 is the output dimensionality of the encoder we are using. Ah, okay, so it varies on the encoder. Am I using a different encoder then? They mentioned something about, I don't think I'm using the same one. Why is that? Let's just, it'll be of the same kind, but it might not be the same. Right, neural search, let's go and look at what the encoder was. So yeah, Mini. So I think because it's tutorial and just keep it lightweight, yeah. All Mini LLM L6 V2 is a distillated lightweight version of MPNet model. Let's just look up that model. Go to there. If in doubt, go to SBERT. I think, so we're on sbert.net now. I think that will tell you how many dimensions each type of model. If you go to the Qdrant site, you can actually get this original article, and it's clearer, and you don't need to worry about your medium 3 articles per month limit. There's a diagram just down here which kind of shows you the flow. Your data set, vectors into Qdrant, then you write an API. You don't have to really. You could call it from Python, but if you're going to build a web front end, then really you probably want an API. You could do that with fast API as they've done here, or you could write your own. You could use Rust, for instance. Hint, hint. Axum, ActixX. Yeah, there's several different frameworks for building an API with Rust. Quite a steep learning curve, but yeah. So here I'm talking about dimensions, and in this article it specifically says 384. So I can't remember where I got this 768 from. Maybe I still have my pinecone head on from yesterday, but so run Qdrant in Docker. They do put the instructions there, but yeah, I think it's good just to do the Webdock one first if you're using Webdock, just to kind of really get to grips with, and the specifics of using the overlay and of uninstalling any previous versions. So yeah, 384 is the encoder output dimensionality. You can also use model.get sentence embedding dimension to get the dimensionality of the model you are using. So that's the way to do it programmatically rather than having to go to sbert.net or Hugging Face. But yeah, critical that you actually have the correct size for your model. If you don't, it won't work, as you saw in my VS Code, the terminal I showed in VS Code just now. So yeah, apologies for this. The sound didn't record when I recorded this clip, but yeah, basically you just need to make sure you're using 384 if you're using this particular model. The model affects what size you need to put in. So after vector params, size equals, and then 384, 768, whichever you find for your model. So next, yeah, I need to put my own data in. I need to, yes, a vector.shape. If you're using NumPy, you can also do. You can get the shape of your, well, it's an array, isn't it? Yeah, so if you search 768 in this article, it doesn't appear anywhere, so yeah, I can't remember where I got that from. But golden rule is make sure the dimension is correct for your model. There we go, vectors.shape. Did I say 364? Hope not. 384, yeah. 384. So 40,474 vectors, and each vector has got a dimension of 384. So I'm going to be kind of combining what I've learned with Pinecone and their documentation with what I've learned with Qdrant. And because Qdrant is free, open source, written in Rust, and it's kind of already, it's yeah, I'm probably going to run, as you can see here, run the Docker container of Qdrant on my Webdock hosting for my upcoming project. So I'm not going to give too much away, but it will be a STS, it will be a semantic search project. And yeah, you can see it's still running. So although I quit the tmux session on Webdock, yeah, you just refresh the page. I know it's got not secure, but really that's I just need to get well, get a domain name. Get domain name and then run, oh, I forget what it's called, certbot, or there's like a free version, a free way of setting up SSL certificates, isn't there? Webdock always provides that for you. Depends what domain name you get. Some domain providers will give you SSL certificates, but you obviously have to pay more for that. So, yeah, that's about it really for this video. I know it's not been overly structured, and it's not actually really been a tutorial as such. It's more been me just kind of covering some problems that I have had, and just kind of looking at getting a project up and running with Webdock hosting, a Qdrant Vector Database. We've looked at making sure we get the dimensions right and how to make sure we can get the dimensions matching the model. So we check the model, and then yeah, this is just like a look ahead to potentially setting up an API that can then query the vector database. So we get some data, we put it into the vector database, and then we write something to query it. So it sounds simple, but as we all know, it never is. So yeah, I'm going to sign off here. Hopefully this is just kind of giving you a taste of how you can put things together. And yeah, if you've looked at the Pinecone documentation, or if you've looked at other kind of OpenAI or LangChain tutorials, just remember you don't have to use OpenAI, and you can just write stuff with for instance, a semantic search model. So there's no cost involved in this other than the hosting. You can write all the code yourself. You can host it wherever you want. If you've got your own hosting already, then the hosting's free, effectively, or it's no extra cost. Qdrant is free, open source, really, without any enterprise support. So yeah, see you soon.